Hello, I'm Dr. Harper. This video is in Supply Chain Analytics Logistics Homework Excel Tutorial Company B, Part 1. Now, your homework may have different numbers, but the procedure is the same. So let's bring up the problem. In this problem, Company B, an international distribution company of containers with corporate offices in Manila, has been expanding warehouse operations in the North American continent to service customers in the Asian continent for over the past 4 years. Leanne Abel, VP of Logistics, has called a planning meeting to discuss possible modifications to shipping schedules because of recent changes in operations. The initial motivation for the meeting is increases in the unit shipping cost due to a series of monetary adjustments within the different destinations. Another concern is changes in the shipping schedule and a total shipping cost due to a 10% increase in the capacity of the Vancouver warehouse. The unit cost of shipping from each source warehouse to each destination site, the capacity in thousands of the warehouses, and the demand in thousands of the destination sites are given in this table. Okay, so the question, before the Vancouver expansion, what is the shipping schedule and minimum cost? After the Vancouver expansion, what is the shipping schedule and minimum cost? And so they're having this meeting because there's been changes, but also there's going to be expansion. And so now she's looking at all the different options before they start making decisions and planning for the future. So let's solve this problem. Let's bring up Excel. And so here it is. Let's enlarge this a little bit more. There we go. Okay, and so let's go ahead and take these right here. Copy this. Okay, bring back Excel. And let's come down here a ways. Boom, boom, boom. And let's paste this. There we go. Make sure there's numbers. Okay, now first of all, this is a typical transportation problem. Okay, let's format this a little bit. Let's bring this open like this, and then format the columns. Bring this down. Format the rows. There we go, and then we format the columns. Okay, there we go. Okay, so let's see here. So the first thing we do, well, first of all, we see that this is 900 and 700, and this is 440, 480, and 520. So this is the problem. Let's go ahead and say the problem. And then down here is the solution. So first, let's solve the problem. Let's copy this again, and then paste it. Just the values. Now we're going to take these out. Now this time this is going to be what is shipped, and this over here is going to be what is received. Okay, and then let's format this, and then let's block this, and this is going to be our decision variable. So let's go ahead and shade this in a little bit. These are the numbers we're going to be changing. Okay, and then to set this up, we want to sum everything that is being shipped from Los Angeles, and that's going to be the total shipped from Los Angeles. Okay, we'll copy this down, and that's everything that's going to be shipped from Vancouver. We just summed those. Now everything that Tokyo receives, we're going to sum the column. So we'll sum this and copy this over, and there's everything that Tokyo receives, everything that Shanghai receives, and everything that Hong Kong receives. So now that we know what's being shipped, okay, right here, this is going to be our schedule, and we know the costs. Now we can come down here, box this in, shade it in, and this is the sum product of the unit shipping costs, F4 to freeze, I guess we don't need that, but anyway, comma, the shipping schedule. And there we go. And so this is going to be in dollars. Okay, and actually we can just actually go ahead and put this in dollars since currency there, and we don't need the pennies. There we go. So now it's really time to set this up, and so we go to data, we go to solver, and bring this over here, and that's our objective function, and we want to minimize the cost. That's a cost. By changing these variables right here, now we're going to add the constraint that everything that is shipped is less than or equal to the capacity. Add everything that is received then is greater than or equal to the demand. Now sometimes, in this case, it'll be equal to, but sometimes it's greater than if we start adding more constraints, like something has to be delivered at a certain time or a certain place, and sometimes it's greater than. And it doesn't matter if they receive more than demand, but what we're trying to say here is we want the demand satisfied, and so the received has to be greater than or equal to the demand. Okay, and then we say okay, and good. Unconstrained variables, these have to be non-negative, and let's change this to a simplex algorithm and say solve, and there we go. We have solver found a solution, all constraints and optimality conditions are satisfied. We say we want to keep the solver solution and say okay. So there's the first part. Okay, well, that's a solution, so let's box that in. We're good to go. Okay, so there's the shipping schedule and there's the cost, and that's the first question, right? Before Vancouver, what's the shipping schedule? What's the minimum cost? After the Vancouver expansion, what's the shipping schedule and the minimum cost? Well, what's the Vancouver expansion? Another concern is changes in the shipping schedule and total shipping costs due to a 10% increase in the capacity of the Vancouver warehouse. Okay. So let's bring back Excel. And let's go ahead and say a 10% expansion. Well, 10% of 770, so 770, that's a 10% expansion. Okay, so then if I say, fine, I'm going to solve this again with a 10% expansion, solver, solve it. Oh, yeah, see, it found a solution. There's a little bit different here. So down here, I'm going to say solution with 10% Vancouver expansion. Left justify here to keep it on the mark here. There we go. And I'm going to take this, Control C, and then copy just the values, and now I know that this is the actual values for that. Now, since I already have that, and that's the shipping schedule, I'll go ahead and block this in and shade it. I'll block this in and shade it, and that's a 10% expansion. But then I'm going to bring this back to 700, solve it again, and the reason I did that is this is the original solution for 700. This is the solution for the 10% expansion. And so here we come up here to data and whoops, do the currency. And so notice it does come down. Okay, when you have more expansion, you can't, in this case, you will decrease the actual cost. So the cost is actually less. Why? Because you have more capacity. You have more things to work with. You can ship things around. And notice your shipping schedule is a little bit different here. And so from these to 61,340 and 61,130, then we can make some other types of questions and start planning for the future. Okay, so that's all I have for this shipping schedule part B for Company B. And I hope this helps. And between now and the next time I see you, I want to urge everyone to stay safe and take care.